Right here, we have the wiring diagram for the vehicle. So see here, we start at the battery. This battery gives power to the ignition switch, and through the ignition switch, we go through this black with white tracer wire, and that gets sent to the ignition coils. 1, 2, 3, and 4. They have this junction here, splits out evenly between each coil here. Then from each coil we have a wire that goes to the ECM and one that goes to this connector here that goes back into the ECM. This would be to make sure that it did fire, so that code that we got on the Chrysler, this is where the information would come from, telling us if we did get that spike or if we didn't. Of course, if we didn't, then there's a problem with the igniter and it did not go off.
So right here we're on our Toyota Corolla, and we're going to be testing out the primary and secondary coil winding resistance. So which one are we starting with here, David?
This would be the primary coil.
Looking at the primary coil right now, hooking it up. Getting about 349 ohms of resistance. And now we're moving to the secondary coil, which we have 4.38 mega ohms. So now we're testing to see if the married coils have continuity between each other. So once we plug in, we should be getting a resistance value. We get 4.39 mega ohms, which shows that there is a link between the two. So here we have the pico scope and the pico wand here. We're going to be looking at the waveform pattern of the ignition coil. So first we're going to come over back here, the car, and we're going to put it on top of the ignition coil, and from that we'll be able to see, you can see it kind of dancing along here. We'll put a trigger on it real quick. There we go. And so you can see the waveform pattern right there from putting it on the ignition coil. So here we have a nice view of the ignition coil waveform that it forms when the ignition coil sends the spark to the spark plug. So you can see the saturation time, the voltage spike, and then the oscillations after the fact of the after the secondary or the primary voltage spike. And we can see that in this one, the spike reaches up to 1.3, 1.4 volts. So right here pictured is the saturation time for the ignition coil during idle. And we can see through the time stamps here that it has a saturation time of 3.233 milliseconds. And we'll be taking a look at the other RPMs to see what it's different. So here we have the same spark waveform, or the ignition coil waveform, but this time it's at 2,000 revolutions per minute. And looking at the timestamp again, we can see that it's actually decreased in time. It is running at about 2.748 milliseconds. So it's showing with the increase in RPM, the spark plug or the ignition coil has less time to fire, so it needs to saturate faster as the revolutions increase. And we should see this also at the next time increment of 3,000 RPM. And so here we have the same waveform with the timestamps with the engine running at 3,000 RPM and we can look at the timestamp, and it's saying that it has 2.562 milliseconds of saturation time, which is even less than it at 2000, which again goes to show that the ignition coil has less time to fire the spark plug because the engine is running faster. This is the last picture that we took off the picoscope, and this one is the ignition coil firing compared to the CKP sensor. And on this one, there's a flat part on the CKP, which is the red color. There's a flat part that goes into some oscillations. That flat part is top dead center, and we took this off of the second ignition coil, so it should just be a little bit far off from top dead center of cylinder 1. But here we see the straight line, and then shortly after, during the oscillations, is the ignition coil firing the voltage up to the spark plug.
Conclusion: there's a direct relationship between coil resistance and the secondary voltage spike. Higher resistance often leads to a higher voltage spike, while lower resistance can reduce it. Dwell time is a very critical component as it allows the magnetic field to build for a proper spark. If the dwell time is too short, the coil won't saturate fully and the spark may be weak. We went over the RPM increases and how that affects the coil. So as the RPM increases, the coil fires more often. We saw this on the picoscope as the dwell time decreased from 3 milliseconds at idle to 2.5 milliseconds at 3000 RPM. Lastly, we talked about how the waveforms can reveal problems. If a coil's voltage spike is lower than the others, it could point to a bad coil or poor wiring with excess resistance. Thank you so much for watching, and we hope to see you again soon.